A dull reddish rock sat in the ground under every ancient city on Earth. Farmers stepped over it. Children kicked it out of the field. Builders packed it into wall gaps to save the good stone. It looked like dirt pressed hard. For nearly all of human history, nobody could do one useful thing with it. And inside that rock was the material that now holds up every tall building you have ever walked past, every rail, every ship hull, every bridge. So here is the real question. How does a person with no chemistry, no periodic table, and nobody to copy pull metal out of a stone that has never once looked like metal? The answer does not start underground. It starts in the sky. Start with the world that iron arrived into. For 2 million years, human tools were stone. Flint and obsidian took a beautiful edge, but they were brittle. One hard blow against bone and the tool was finished. Then, about 5,000 years ago, something changed. People found that certain green and blue stones, pushed into a hot enough fire, would bleed out a soft, shining metal. That was copper. Copper could be poured, hammered, and sharpened again, but pure copper bends when it meets something tough. So they mixed it with tin, about 9 parts to 1, and got a metal harder than either parent. They got bronze. Bronze ran civilization for 2,000 years. The first cities, the first writing, the first empires, all of it cut with an alloy that needed 2 ingredients, and that was the weakness. Copper is common, but tin is rare. It sits in a handful of places: Cornwall, Central Europe, the mountains of Afghanistan. An Egyptian workshop needed metal that had crossed a continent to reach it. One war, one sunk fleet, one broken treaty, and an empire lost the ability to make its most important tool. Meanwhile, the cure was lying in the soil under their feet. They had no way of seeing it. Iron is the 4th most abundant element in the crust. It is over 5% of everything below you. Mountains hold it, rivers carry it, and the red in clay soil is it, rusted. Yet people who built pyramids and wrote law codes could do nothing with it. The reason is one stubborn fact of chemistry. Iron loves oxygen. Given air and water and enough time, metallic iron turns into iron oxide, which is rust. On the surface of this planet, that process finished long before we arrived. So every scrap of natural iron metal had already become stone. What an ancient person saw was red rock, heavy rock, rock that behaved exactly like rock. There was one exception, and it fell out of the sky. Nickel-iron meteorites are broken pieces of the cores of small dead planets. When one survives the fall, it lands carrying something Earth's surface no longer has: pure metallic iron alloyed with a little nickel. Everything about that object is wrong for a rock. It is far too heavy. It sticks to a lodestone. Hit it with a hammer and it does not shatter, it dents. Ancient people knew immediately they were holding something other. Egyptian scribes wrote iron with a name that reads as metal of heaven. The Sumerians combined the signs for sky and outside. Hittite ritual texts call it the black iron of the sky. That agreement across 1,000 miles was not poetry, it was an accurate description. In an Egyptian cemetery from about 3200 BCE, there are 9 small tube-shaped beads, hammered from a meteorite and thick with nickel. Tutankhamun was buried with a dagger whose blade is 11% nickel. Assyrian merchants priced iron at up to 40 times silver, weight for weight. So iron was already known, already touched, already treasured. It just did not come from the ground. Pulling it out of the ground needed a fire that nobody on Earth could build yet. Here is the wall. Copper melts at 1000 Zeus, 85 degrees Celsius. Bronze melts lower, near 950. A good Bronze Age kiln ran somewhere between 1000 and 1150, which was exactly enough. Pure iron melts at 1538. That gap is not a small engineering problem, it is a different class of problem. And there is evidence people tried. Iron-rich rocks went into copper furnaces, and the smelters waited for metal to pool at the bottom. Nothing pooled. The stone sat there red-hot, solid, and useless. Every sensible conclusion said iron was a rock that stayed a rock, so the entire Iron Age had to happen below the melting point of iron. It did, and the thing that made it work came out of a furnace looking like a burnt sponge. Nobody set out to build the furnace that could do that. 3 improvements arrived slowly, and all 3 were made for bronze. First, charcoal. Wood baked with almost no air becomes near pure carbon, and it burns hotter and cleaner than raw timber. Second, height. A tall clay shaft makes a chimney, and rising hot gas drags fresh air in at the base. Taller shaft, stronger draft, hotter fire. Nobody knew the physics. They knew tall furnaces ran better. Third, the bellows. Leather bags pushing air through clay nozzles could hold 1200 degrees for hours. Copper smelters wanted every bit of this to melt copper faster. What they had actually built was a machine for a reaction they had never heard of. Then iron rock went in. It may have been deliberate because iron-rich stone was sometimes added to a copper melt as flux to help the waste separate. Either way, the ore entered a shaft burning near 1200 degrees, and it did not melt. Something else happened instead. Charcoal starved of air does not burn cleanly. It makes carbon monoxide, and carbon monoxide is desperate for oxygen. As that gas climbs the shaft, it meets the iron oxide and takes the oxygen off it, atom by atom. No melting is required. The rock is quietly turned into metal while it is still solid. What collects at the bottom is not a shining pool. It is a gray porous lump of iron grains fused together, still full of glassy slag, still holding the shape of the stone it came from. It is called a bloom, and it is genuinely ugly. Someone broke open that furnace expecting copper or expecting failure and found an object nobody had ever seen. It was dark. It did not shine. But hot, under a hammer, it did not chip and it did not crack. It squashed. That is what metal does, and only metal. The bloom on its own is still worthless. Left as it came out, it would crumble, so the real work started at the anvil. Hot hammering squeezes the slag out through the surface like water out of a sponge. It crushes the holes shut and presses the iron grains together until they weld to each other, without anything ever going liquid. Hours of that gives you wrought iron, and wrought iron is tough. Bend it hard, and it stays bent instead of snapping. But it has one flaw, and the cure was already sitting in the fire the smith was working in. The flaw is softness. A wrought iron edge goes blunt against bone, hardwood, or another blade. Good bronze holds an edge better. What closed that gap was carbon, and no blacksmith alive knew carbon existed. They knew a different thing. Iron that sat for hours buried in burning charcoal came out harder than iron worked quickly. Above about 900 degrees, the crystal structure of iron opens up, and the gaps between its atoms happen to fit a carbon atom exactly. Carbon walks out of the charcoal and into the metal. Less than 1% by weight changes everything. Cool that fast in water, and the structure locks hard enough to scratch bronze without effort. That is steel. It was found by men who could teach the recipe perfectly and explain none of it. Now the part that turns the story backwards. Iron did not win because it was better. For centuries after smiths in Anatolia learned the trick, iron stayed second-rate. Plain wrought iron is softer than a well-made bronze sword. Early iron tools bent in use. Then, around 1200 BCE, the eastern Mediterranean fell apart. In about 50 years, the Mycenaean palaces went dark, the Hittite Empire stopped existing, and coastal cities from Cyprus to the Levant burned. Historians still argue about the cause. Nobody argues about the result. The long trade routes died, and the tin died with them. So bronze went scarce in exactly the places that ran on it. Metalworkers looked around for what was left. What was left was iron ore, everywhere, and furnaces that already knew what to do with it. Civilization did not upgrade to iron. It crashed into it. Given a free choice, the ancient world kept choosing bronze. Given an empty tin route, it chose the metal under its own feet. That accident changed who was allowed to own metal. Bronze needed 2 ores and a continent of trade, so tools and armor stayed with palaces and elites. Iron needed a hillside, a forest for charcoal, and one man who understood the fire. A farmer could own an iron plow. A common soldier could carry an iron spear. And to everyone watching, the man who made it was doing something impossible. He fed dull red stones into a fire, pulled out a shapeless cinder, beat it flat, and handed back a blade sharper than anything the village had seen. No wonder almost every culture gave iron its own god. Hephaestus, Ogun, Goibniu, the dwarf smiths of the north. The blacksmith was the one alchemist who actually delivered. Stand in a city and look up. The frame above you is steel. The floor under your feet rests on steel, the concrete is threaded with steel, and the train that brought you here rode on IT. Every gram of that was once a dull reddish rock in the ground. Every gram passed through a fire where carbon monoxide pulled the oxygen off iron oxide and left the metal behind. The furnace running in Wuhan or Pittsburgh today is doing the same reaction as a clay shaft on an Anatolian hillside 3,000 years ago. The scale is different by a factor of millions. The chemistry has not changed at all. The rock that people stepped over for 4 billion years is now holding the sky off our heads. It never stopped being the same rock. We just finally learned what to burn next to it.